Hey everyone, welcome to my little series on debugging. So this video, and really the series of videos that are here, came about mostly because of the types of questions that I get and other instructors get about debugging. The problem with debugging, and while we do teach it in GAP 125 and a couple other classes on the design side as well, we do teach it, but it's one of those skills that I can't just sit down and show you how it works and then expect you to remember every little thing. There's lots of little fiddly bits, and you don't need them until you need them. And so it's one of those things that I always get these questions and people come back to me and they're like, I don't remember how to do this, or I know we talked about this, but I don't remember this. And it's one of those things. I mean, I think we've all gone through that when we were first learning how to use some of these tools. So I created this video, and there'll be other videos as well. I think there'll be 3. This one is going to go over the basics. And so when I say basics, what I mean are breakpoints, the Callstack, and watches. So if you feel like you have a good handle on those 3 things, you can skip this video and move on to the next one. The next one I'll talk about more advanced debug concepts, data breakpoints and that kind of stuff. And then I think I'm going to create a 3rd one, which is going to be much more about the theory of how to debug and how to solve problems, and just how do you deal with something broke in the game, now what? So I think that's kind of what I'm going for these videos. But this video is going to really talk about these 3 things. So let's get started. Breakpoints. So a breakpoint, if you imagine your code as looking something, like this, maybe you have some lines and then maybe there's some, if statements or whatever. It doesn't matter. But this is a visual representation of what your code might look like. A breakpoint is a little device or a little thing that you set. You say, I'm going to set a breakpoint here on this line. And when you run the game in the debugger, it will stop execution right before that line. And that's an important distinction. It will be before the line. So that means that line has not yet executed. And that's all that it is. From there, you can then sort of execute the program step by step. And that's the whole purpose behind breakpoints, is it allows you to stop at some point and then execute some part of the program step by step. One thing that is somewhat tricky to wrap your head around is, while it may feel like you're instantaneously jumping around, you're not. It's executing code. So you're never skipping anything. It's always running everything that's there. So that's kind of how breakpoints work. Let's see a very simple version. And so first I have to kind of show you this program. It's a relatively straightforward but sort of useless program. And I'm actually going to move this guy over here and do this and change to probably this and then that. So this will let me kind of highlight things. Okay, so what we have is here in main, I basically have this part. And what this will do is it will create a string called name, and it will set that name to cat. So that's all this does. Then what we have, I'm going to actually try and do this slightly differently. That's not quite what I want, but I think it can be. Yeah, it's closer. What if I do this guy? Yeah, that's what I want. Perfect. Okay. So I can move you back. Great. Yeah, so that's kind of what this block of code does. Then I call this a init function here. And I check to see if it returns false. If it does return false, I print some error, and I keep going. So init is up here. it takes in a value, which I pass in 50. And so it sets this global number to that value, then checks to see if that number is greater than our like default or our sort of constant size here. If it is greater, then return false. So we sort of limit it in that way. Otherwise, it does this loop. So this loop is just going to go through and set this like float array to the value of the square root of whatever I is at this particular point. Let's see. And I think, yeah, and then down here, it's going to print the name, and then that's it. So it does nothing. I mean, that's basically what it does. It basically does nothing. And that's the point. We just want something really simple for us to be able to look at. So I'm going to close this. Actually, I probably do still want this. So let's compile. Great. Now, if I just hit Control F5, it's just going to say name is cat. Control F5, if I go up here, I can see it's start without debugging. And the reason I mention this is because I see a lot of people do this. This is like the most common thing I see sort of newer programmers doing down in the lab all the time. If this is you, if you run the game or run whatever your project is, I would break that habit as soon as possible. You want to debug, start debugging. And that's F5. So if I hit F5, it will run the game in the debugger. Notice Visual Studio just changed its interface, and all sorts of fun stuff happened. And that's great. That's exactly what we want. Because there are several reasons. The simplest reason is if the game crashes, I immediately know what happened. And I'll give you a very simple example. Let's say that I have this pointer and I set it to null pointer. And then let's say that I try and, you know, see out star p pointer. Right? This is gonna die. This is gonna crash. Oops. Count. This is gonna crash because null pointer, I'm trying to dereference a null pointer. It's a classic crash. So if I run this normally, what I get is a crash. This doesn't help me. Now I can go to debug the program and I can usually figure out what's going on there, but that seems terrible. Whereas if I hit a 5, bam, there it is. Exception thrown. Exception thrown, read access violation. P pointer was null. Great. It tells me exactly what's going on. I'm trying to access the pointer and this pointer's null. That's it. That's the problem. I'm here at this line. It broke on this line. This little X means this is the exception that was thrown. This little yellow arrow says this is the line that's trying to execute right now. This is where I am in the program. So here you can use all of your debugging tools that we're about to learn to figure out what happened. So always start with the debugger, unless there's a real specific reason not to. Always start debugging. There are only a few reasons that I can think of not to do it. And most of them are sort of advanced things, like if you're trying to profile it, if you're running release mode, or if, I know on The Sims 4, for instance, running the game for a while didn't want to run. I know that we attached the debugger usually after loading, because loading took a long time, and so on. For the most part, just hit F5. And it's so easy. And it's even faster than Control F5, which is an entirely extra key. Okay, breakpoints. So to go back to our little thing here. Uh-oh, where'd you go? I actually have no idea where it went. Windows, reset layout. Oh no, it wasn't it. Anyway, so I actually don't know where my stupid thing is. Hold on. I'll just zoom way out. There's... Oh. Maybe I deleted it accidentally, because I don't see it at all as I zoom way out. Cool. So let's reset. Canvas view, and we'll just live with that. Okay, moving on. Let's set a breakpoint. setting breakpoint is pretty easy. There are 3 major ways to do it. You can go into this debug toggle breakpoint. And you see this little red dot up here. And I can toggles it on and off, right? So if I go back here, toggle breakpoint. That's sort of slow. This thing also tells me there's a hotkey, which is F9. I can just hit F9. Dink. That's pretty great. And the third way is I can just click in this margin where breakpoints are. And you can have as many breakpoints as you want. And just keep going. In fact, there's a breakpoints window, which I don't have open. But if I go to debug Windows breakpoints, here's a little breakpoint window. And you can double click on them and they'll take you there. And it's all that kind of stuff. I'm also going to highlight them and delete them because maybe I don't want all these breakpoints. So let's watch this happen. So I'm going to set a breakpoint here on name equals cat, and I'm going to hit F5. So what happened is my program executed as normal. Then it reached this point where I got this line, and it says, okay, I'm here and there's a breakpoint. So before I execute this line, I'm going to stop. And so I'm here, I'm stopped. Now there are several things I can do at this point. And most of the debugging features, in fact, pretty much almost all of the debugging features and debug features, you have to be broken somewhere. You have to be at a breakpoint somewhere. There are basically 4 things I can do. I can maneuver around. I can continue, and they're all up here. So you can see them all right here. I can continue, oops, which is really this button. And I can do these things here. And so this guy is continue. Continue says basically keep going. That's what continue means. It'll just keep executing until you hit another breakpoint. The breakpoint will stop, of course. And then these are all of your what are called, oh no. Oh, that's interesting. I don't know what's going on there. But basically, these are your step functions. So these are steps. A step is, well, we'll talk about it in a second. So, how does this work? I can just hit this button, and I will just keep going, as if nothing happened. And it's great. Let's show another example. I'll set a breakpoint here, in the middle of this loop. Now this loop, if I hover over this guy, we can see it's going to loop 100 times, right? Float array equals 100. So, let's change this to 10. Actually, let's change this to 3. Why 3? Because if I want to... Uh-oh, something happened here. Oh, of course something happened here. Because I'm passing in this. This is going to fail. Great. So I'm here. This is the first time that we're calling. In fact, I can hover over this and it'll tell me I is 0. I can hit continue. It looks as if nothing happened, but it did. I is now 1. I'm in the next version of the loop. I can run again. And then again. Okay. So we saw it happened exactly 3 times. So it keeps going until you hit a breakpoint. Until you hit another breakpoint or the same breakpoint or whatever. So that's continue. Now, the other 3 are also very useful. I'm actually going to set my breakpoint here and hit continue and then close this. So here I've stopped at a init right before I have called init. So now I have these step functions. I have step into, step over, and step out. Step into says step into whatever functions are on that line of code piece by piece. So if I hit step into now, what I would expect is that I'll be at the top of the init function. Notice that my little yellow arrow, which always points to where you are right now, is there. And if I hit step into again, I'm here. And if I hit step into again, I go to the next line. Now there's no functions to call here. That's why it's not doing anything, because gnum and nunum, I mean, these are just integers. So there's no function that's getting called. But there is, if I keep going and then go again, here I'm calling the square root function. If I step into this, I will go to the square root function. Here it is. This is the square root function in, looks like core CRT math.h. Now, this is not going to be super exciting. If I hit step into here, it does not step into this function. And this is one caveat of step into. Step into will only step into code that you have. It will not step into code that you don't have. So I don't have the C runtime code here. I don't have, any of that implementation, so it's not going to do it. It will step into any code that you have, though. Now I'm going to stop executing. You can do this with this little stop button. I'm going to move my breakpoint back here to where it was. And I'm going to delete this guy. I'm going to run again. Now I'm going to hit step into here, and we're going to see something kind of interesting. I've stepped into here, and some crazy function somewhere. Now, if you've taken GAP 225 and you know what overloaded operators are, this may look somewhat familiar. This is the overloaded assignment operator for string, for standard string, specifically basic string. So the reason why I'm here is because I do have the code for this. This is a template, so templates have to live in the header file. So I have all this code. I can keep hitting F11, which if I hover over this, step into is just F11. I can keep hitting this, and I can just keep going deeper and deeper in, not Sterling, but I can just keep going and going and going. Like, it gets nuts. That's not particularly useful. We need another way of being, it can be, but we need another way. I don't think if I'm trying to debug something here that my problem is going to be in the string assignment operator. So we'll run again. We have another tool. It's this middle button here called step over. This says execute this line of code as it is. Don't bother stepping into any functions. Just keep going. Now, the name is sort of tricky because it implies that you're skipping code, but remember, you're never skipping code with any of these tools that we're using right now. There are ways that you can skip code, and the advanced video will talk more about those, but in this video, none of the things I'm showing you will skip anything. So it fully executed this. If I hover over this, it says cat. So that's the next tool that I have. Now the third tool that I have, and step over is pretty common. If I do it here for a init, right, it's going to be the same thing. Step over init. All I did was hit this button, which is F10, and it stepped over init. It called it, init got called, but so if I hover over gnum, it says 1 because that's what we set it to here. But it never, we just execute it normally. And I would say much of the time I'm using step over, and step into I use quite a bit as well. I don't know, I guess I don't know that I use them both constantly, so I guess I can't really say which one I use more often, but they're both very common. Use F11 and F10, use the hotkeys as much as you, I just strongly suggest learning the hotkeys. Moving your hand, it seems dumb, I guess, to say it, but moving your hand, 12 inches or 18 inches to the right to where your mouse is will lose you time during the day. It really will. So learn the hotkeys as best you can. Touching the mouse should be more rare. Honestly, I usually have my left hand position over F10 and F11 so that I can step as I'm going, and I have my right hand on the mouse so that I can just hover over stuff as I move forward. Okay, the last thing I'm going to talk about is step out of, which is this guy. So step out of is a fascinating little one. It's sort of like a big step out in a way. So if I go down here, I stepped over this so that I didn't step into this assignment operator. Now I'm going to step into init. And so now I'm inside of init, and maybe I go here and I go, oh, okay, this didn't fail. There's only 3 here, but when I first did this, it was 100. I don't want to step through all these. I know this is going to succeed. I'm done with this function. I just want to step out of this function and continue executing normally. So what step out of does is it does exactly what I just described. It steps out of the current function that you're in, this init function in our case, and it will step to the very previous thing, the thing that called me, in our case, main. So it will step out of this and out back here to main. And again, it will execute every single line of code to get there. So it doesn't It doesn't skip this for loop. It happily goes through this for loop. So if I step out of and I hover over this for loop, I can see that it contains 0, 1, and 1.414, which is what I would expect from the square root of 0, 1, and 2. So it happily will run all this code. You're not skipping code. You're never skipping code by doing this stuff. I'll tell you when you're skipping code. So that's it, and then we can step and step and so on. I use step out of quite a bit. I use step out of if it's like, okay, this isn't my problem. Or sometimes you accidentally step into something. You're like, whoops, I didn't mean to step into this. Well, I'm just going to step out of this. It will still run all the code and everything, and I'll be here. So that's that. So those are breakpoints and how to kind of maneuver in code a little bit. To review, you can... Oh, I think I still have this up. Hold on. Whoops, not you. Yeah. So to review, you have continue, you have step into, step out of, and step into, step over, and step out of. This is grouped along with all of these, so I feel it necessary to point out that what this button does. This just says take me to wherever I am right now, and it's useful. So if I'm like way somewhere else, or I'm in some other file somewhere, and I'm like, where actually is my instruction pointer? Where am I? You can just press this button and bam, there, here. This is the line of code that it's right about to execute. So it's useful. All right, removing breakpoint, stopping. That is how breakpoints work. Now, the second thing I want to talk about is I want to talk about the call stack. So I'm going to do all this stuff again. I'm going to set a breakpoint here in init. So here I am inside of init. Now, you've probably noticed it, but down here, there's this guy. This whole window, whoops, is the call stack. This whole thing is the call stack. If you don't see it, there's a tab here, which may not be selected. Maybe this tab is selected, so you might have to click this. And worst case, you can go to Debug, Windows, Call Stack. I have my own sort of layout. I don't know what the default is. It might actually be over here, but it'll be a little tab called Call Stack. Okay, so this is the call stack. There's basically one major piece of information here, which is, well, I guess there's sort of 3 columns. This language is sort of less useful for us, but it's more useful if you're debugging a multi-language application. We use this, for example, more often in like The Sims Medieval, which use C# and C++. But you basically have one per line, the function that you're in. So this is one function, here's another, and so on. And by doing this, we can watch where this guy has come from. We are here right now. We're in this function based on this symbol. This is where we came from and where that came from and so on. So you can think of each function as it's sort of a roadmap. So right now I am here. Who called init? Well, we know because it's a tiny program, but you could be in a very large program. Who knows who called this guy? Well, if I go here, I can just double click and say, oh, it was called in the main, you can see debugging.exe in the main function on line 30. Here it is. If I go backwards, I can say, oh, in line 78 in some, C runtime thing somewhere, and so on. You can just keep going backwards. If you go too far back, you'll get something like this, which means you're in like Windows, you're in the operating system's code, basically. So it's a little less useful with only just a couple of things here. But if I go back here and I just step into the assignment operator and all this stuff, I can be like, where am I? So I'm in a function called length, which in turn was called, here's length being called inside of assign. This in turn was called an operator equal. We can see what it was called there, and so on and so forth. Now, this says line 2283. The actual assign call is on 2282. Sometimes these things will be slightly off. It has to do with how the actual code was generated and so on. Just be aware that sometimes these will feel slightly off. You just have to use your own judgment to see where did you come from. Okay. I'm going to step out of each of these functions, and notice I had to do it 3 times. One way, if you kind of get the call stack to think about step out, by the way, is that it will step out. It will basically step out of whatever this function is and back into this function. So it will call whatever this next line is. That's another way of thinking about it. So that's really it. That's all the call stack does. If I go to a much more complicated example, like this guy, what's a really good example? So this is my own project. Here's journey camera on update. Who calls this guy? Well, if we run this and we let the camera go, we can see what the call stack says. Journey camera : on update. This is where we are now. It was called by process manager update processes. Specifically, here's where it's being called. This is super useful because probably in update processes, which is the case here, these are generic things. When you dig into some of the later classes, GAP 255 and so on, you'll learn about things like polymorphism, or maybe you already know that stuff. In turn, this was called by logic. So this, and there are many places, where update processes is called. If I just search for this function, you can see all the places where it happens. It's actually called specifically in 2 places. So this shows me where was it called. This shows me here, oh, it's in this logic update. This is who's calling logic. This is called in the main loop, and so on. So it's a really good way of figuring out who's actually calling me and why. This is especially important because a lot of times a bug is bad data. So a lot of times it's like, well, let me set a breakpoint for when I got this bad data, or an exception just gets hit. Let me go backwards and see who's calling this and why. It's really good to be able to do that kind of stuff. Okay, that's it for callstack. Callstacks are relatively straightforward, I think. It's just what functions were called to get to this place. The last thing we're going to talk about are watches, and we've already kind of looked at some of them. So let's run. Now, the simplest version of a watch is name, or hovering over stuff. I can just hover over this. Name is an empty string. Now, think about in your own head why this is an empty string right now. And I'll give you a few seconds, and you can pause the video if you want. So name is an empty string right now because this breakpoint and this little yellow line means I am about to execute. It has not yet executed this line. If I press F10 or step over, it will now have executed this line, and I can hover over name and it will happily say cat. It also says it down here under autos. So these are your watches. There's a bunch of different kinds. If I go to debug, Windows, this whole little section, this little, you can see the little vertical line there, this whole section are your watch things. There's the watch window. There are 4 separate watch windows. There's the autos window, the locals window, the immediate window, which I'll open for fun. What else is there? The Python debug interactive window, which will do nothing for us, but is great if you're using Python. The intermediate window I'm not going to go over. It's its own thing, so I'm going to close it. We're not concerned with that much at this point. I'm also not going to go over threads or modules or any of this other stuff. Locals is every local variable. I find that I almost never use it. In fact, I'm going to close it. But if you want to see all local variables, there you go. Auto and watch are the 2 that I use the most. So autos is basically everything that Visual Studio thinks you should probably know about, and it constantly changes. So if I step into init, notice that it cares about gnum and nunum. Nunum being the parameter and gnum being the thing I'm about to set. It doesn't care about G floats or any of this other stuff yet. But if I keep stepping over stuff, see, now it cares about the size of the array because I'm about to check things. So it sort of dynamically changes and says, here's the data I think you care about. I use this sometimes. Some people I know, this is their go-to window. A lot of programmers, this is the window they always have up and they're always looking at it. Personally, I use hovering over things mostly, or I use explicit watches, which is what this watch window is. So there's watch 1, 2, 3, and 4. There's no difference between them except it allows you to have different watches. And it can be used like different sets of watches. All this is here you can type in the name of any variable or often expression. For example, I could just type in 10 plus 5 and it shows me the value of 15. More usefully, I could say new num. So new num, it shows me new num, but I could say new num times 5 or whatever I want. Like you can type in some expressions. You can't make changes, so you can't call functions, for instance. But you can do several things in here. Okay, so let's just watch what's about to change. So G floats. Let's look at G floats. Right now, G floats is 3 zeros. It's 3 zeros because I got lucky, basically, and memory, or maybe the debugger set it to 3 zeros. I never initialized it, so who knows what it could be. Although maybe it initialized it because it's a global. That sometimes happens. I can watch this be set. Now watch this watch window. Watch the watch window down here, right? This whole section. Watch this. Oops. Big guy. Watch this whole area as I change things. And for fun, we'll show you genome as well. Okay, here it goes. I'm going to hit F10. Nothing happened. Well, that makes sense because I'm setting a value of 0. Let's do it again. Oh, something happened. Something changed. So this red means something just changed. Like in the very last, since the last time I broke, basically. Since the last time I was looking at this kind of screen, something has changed. And we can see that this 1 got set to, or index 1 here got set. Kind of cool that I can have this whole array. I can just see the array. That's pretty sweet. Let's do it again. Oh, now this changed. Really useful to just catch your eye. This is also why a lot of people like having autos up, because they can just see that things are changing and watch things change. Usually when I'm debugging, I care about a particular set of data. So I'm watching for a particular thing. So I'll set watches in there, or I just have a ton of data that I don't feel like dealing with. And so I'll just have the things I care about in here. You'll find the way that you work the best. Play with it. This is what watches do. It's really nice. Now there's one other thing that I want to show you with watches, and this is a feature of autos. You can only see it in autos. Let's say that I step over this, and then I step over init. What did init return? Well, there's no simple way for me to see, except here in here in autos, it's telling me. I can't see it by hovering over anything. This isn't going to tell me. And the reason why I had that little slip of the tongue calling it an R value is because it is what is known as an R value. But here it will tell me. This is super cool. I use this all the time. What did this function return? Great, it returned true. I don't have to care about init because init succeeded. Let's keep going on whatever the next thing is. It's very common that if I have a big function that's like initializing a bunch of stuff, I'll just keep stepping until one of them fails. And that sort of thing. So that's watches. Watches, I think, are relatively straightforward. You can do a lot of cool things with them. It's really about inspecting data. The two major ways of doing it are hover over the thing, and you can hover over a lot of stuff. I can just hover over gfloats, open this guy up. And it doesn't always work. So like new num doesn't exist anymore. This data is long gone. I can't hover over this. If I type in new num, it's going to be like, I have no idea what you're talking about. So remember that C++ scoping rules still apply. I'll give you one last example of that. I have a variable called name. I can look at it right now. Cat, right? There it is. If I step into init, name still exists, but I can't see it. It's going to gray it out and show me the last value that it knows. But I can't actually see it, technically. And in fact, if I run this and I delete this, and then I do this and I step in here, and then I type in name, it's going to have no idea what it is, right? Has no idea. However, It's C++ scoping rules. So if I go into the Callstack and I just go backwards, and this is just showing me, this is just changing my context. Oh, now it knows what name is. I've not moved the code pointer, but I've moved my context. And this is sort of an advanced concept. But now I'm looking at it from the point of view of being this line of code. So now I can see things like name. So if you're looking for certain variables that you can't see, jump around in the call stack. This is a read-only thing. I'm not making any changes. I'm not moving to any of these lines of code. I'm just changing what the compiler or what the debugger is looking at in terms of context. And it kind of has to do this, right? Because I could create a variable in here called name, just like I have one here. Okay. So we've learned about three sort of major tools. We've learned that there's breakpoints, and that once you have a breakpoint, you can move around sort of by doing these steps or just continuing, but you can kind of watch code execute line by line. And we've also found that you can look at data while you're doing that, or that you can even sort of jump around in context and just see where you came from with this call stack. Those are the major things. My strong suggestion is that you play with these things and that you use these things all the time. Use it just to verify that the code is working like you'd expect. How would you expect this code to run, right? I would expect this to run 3 times. There, it did. I would expect init, this not init, I would expect this cout below me not to get called. Good, it got skipped because this if statement didn't get run. Perfect. So do that. The very first thing that I do when I start a new project is I get into the debugger and I watch things happen. I set a breakpoint somewhere and how did I get here? Where am I going from here? Let's just see what happens. Really, really powerful tool to do that. Okay, so that's the end of this video. Next video, I'm going to talk about more advanced concepts. Before you watch the second video, whenever I get around to posting it, I would make very, very sure that you understand these core concepts really well. Know about breakpoints, know how to set breakpoints, know about the call stack and why it's important, how to maneuver in the call stack, and know about watches and how to look at variables. Because the advanced things I'm going to show you assume that you have a mastery of those 3 things. Okay, and if there's any questions, hit me up on Discord or wherever, and good luck.